Okay, so here's the third part. Just step a little bit away for your shadow. Okay, so we've seen this equation a lot, right? This is another thing Fermat studied. A squared plus b squared equals c squared. Where's that from?
I think that's the Pythagorean theorem.
That's the Pythagorean theorem. Do you know any examples of numbers that satisfy a squared plus b squared equals c squared?
I think it's maybe 3, 4, and 5.
Right? 3 squared plus 4 squared does equal 5 squared. 9 plus 16 equals 25. Do you know a different example?
No. Maybe does 13, 14, 15 work?
13, 14, 15 does not work. But there's 5 squared plus 12 squared. So 144 plus 25. Can you add that up?
That's 169.
Which is what?
13 squared.
13 squared, and I think there's 7 squared plus 24 squared plus 25 squared. There's lots of interesting ones.
Yeah.
You can also multiply. Like if you multiplied all these numbers by 2, 6, 8, 10. 6 squared is what?
Is 36.
Plus 8 squared.
Which is
64. What's 36 plus 64?
100. 10 squared.
Okay. So lots and lots and lots of integers satisfy the Pythagorean theorem, and it comes up in geometry, right?
Cool.
But no one had ever been able to find anything above 2 that works. So no one had ever been able to find a cubed plus b cubed
Equals c cubed.
C cubed.
Or above.
or above, right? And there were some ones that were close. In fact, just in the last video, we saw that 12 cubed is 1728, and 10 cubed plus 9 cubed is 1729. It's a near miss.
Yeah.
Shoot. So close, right? But no one had ever been able to find anything that was exactly equal. And Fermat claimed, well, he didn't prove, he claimed that if n was bigger than 2, it was an integer bigger than 2, so a cubed plus b cubed equals c cubed, or a to the 4th plus b to the 4th plus c to the 4th. There were no solutions. And he wrote in a little notebook, he said, I know how to prove this, but, oh, you know what? I just don't have enough room in my notebook to write it down.
Maybe we don't have maybe if he had this whiteboard, maybe he could do it.
Maybe he would. You think that would work on your homework? You say, oh, I know how to do this problem, I just don't have enough room.
Maybe.
Maybe, yeah. Don't try that. So anyway, so it wasn't until 1994 that somebody actually proved it, that there were no solutions. It was a mathematician at Princeton named Andrew Wiles.
I guess he had enough paper.
He did have enough paper. You know what? He worked on it for like 10 years all by himself.
Whoa.
It's pretty cool, actually. I was in graduate school when it happened. So finally it was proven. And that was one of the most famous unsolved problems in all of math, by the way.
Like the Collette's conjecture.
Very similar to the Collette's. It was probably even more famous than the Collette's conjecture. Do you know some other unsolved problems in math?
The largest prime number.
Well, the largest prime number, I guess someone would know, but people know that there's not a largest prime number.
There's infinite.
There's infinitely many primes. People know that. Ever heard of any other unsolved problems? Have you ever heard of the Goldbach conjecture? No?
I thought so.
That's probably the most famous unsolved one right now.
Hmm.
It says any even number is the sum of 2 primes.
Cool.
And for any even number anyone's ever checked, it works.
Yeah.
Like what's 14? Give me 2 primes that sum up to be 14.
7 plus 7.
7 plus 7. Give me 2 primes that sum up to be 20.
20 is 15 and... No, it's 7 and 13.
7 and 13. Give me 2 primes that sum up to be 30.
Well, 20... Well, 1 doesn't really count, but...
No.
23 and 7.
23 and 7, yeah. So any even number you try, someone has figured out a prime, but nobody knows if it works for every number. So that's an unsolved one. Anyways, this is pretty cool. So powers, logic. Logic we talked about where if a number is satisfied, a prime number satisfies Fermat's little theorem.
Yeah. But
And so if it doesn't satisfy it, it's not prime. But if it does satisfy it, it might be like 17 and 29. It might be like a fake prime.
Yeah.
And that was the logic, that was the powers, and that was the prime numbers. All right, high five, guys. Good job. That was actually pretty fun. Yeah?
Yeah.